Hello and welcome. So today we're going to talk about NumPy. If you're into data science and machine learning, knowing NumPy is a bare minimum. Other machine learning and data science libraries are on top of NumPy, and this library is very powerful. In this video, I will explain why NumPy is very useful, and I will walk you through some basic operations so that you can see how NumPy works. So without further ado, let's dive in. So what is NumPy? As I mentioned before, NumPy is the fundamental package for data science and machine learning in Python. It is the foundation of many other libraries such as pandas, matplotlib, or scikit-learn. And most importantly, it allows us to deal with multidimensional data in a fast and efficient way through its array object. So you can think of this as a Python list or a Python array. So why do we want to use NumPy when we already have a Python list? The main reason is NumPy array is extremely fast. And a Python list is quite slow. So why NumPy array is so fast? So there are two main reasons. The first one is locality of reference. So in a NumPy array, all the variables are stored in contiguous memory location. So that means it takes less time to access those variables compared to a Python list where the variables scatter everywhere in memory, so it takes longer to gather them in one place. And the second reason is most NumPy operation is written in C, and C execution is much faster compared to Python. So that's it for the conceptual overview of this library. Now I will walk you through some basic operations so that you can see NumPy in action. So welcome back to the coding walkthrough. I have prepared some code here. I will upload all of this code to my GitHub account. Feel free to access it after watching this video. The link is in the description. The first thing you need to do is you need to import the NumPy library. I'm going to call import NumPy as np. If you don't have NumPy in your machine, you have to install it. I already have it, so I don't have to do that anymore. But to install NumPy, you can use the pip command, pip install NumPy. So I'm going to run this block. Alright, so now NumPy has been imported to the Jupyter Notebook. The first thing about NumPy is the array. That's the core fundamental of this library. So to create an array, you can call np array and then pass in a normal Python list. So in this case, I create an array A that contains 3 values, 1, 2, and 3. Each NumPy array will contain several attributes. So the first one is ndim, which is the number of dimensions. The second one is the shape or the shape of NumPy, the data type. So the type of the variables inside the NumPy array. And the item size, which is the item size in bytes for each element in the array. So I'm going to run this block. Alright, so we can see that the array is 1, 2, 3. The number of dimension is 1 because this is a 1D array. The shape is 3 ones because we have 3 elements and it is a 1D array. The data type is int64 because we are using integers. And the item size byte is 8 because each int64 have 8 bytes. So we can see that all the integers are converted to float. And the data types of the variables are float64. So in NumPy, all the variables in the array must be the same type. That's why NumPy is very fast, because it stores variables of the same type, and all of these variables are stored contiguously in memory, so it takes less time to access the variables. So next, we're going to do some basic operation with a NumPy array, including indexing and slicing. So now I create a NumPy array contain 9 elements. So this is a 3x3 array. So to get a number at a specific row and column, we can easily use a bracket, then specify the row and specify the column, separate them by a comma. So here we try to access the element at row 0 and column 2, and the element at row 1 and column 2. So in this case, the element at row 0 and column 2 is 3, and the element at row 1 and column 2 is 5. So the output should be 3 and 5. Now, so you can see 3 and 5 here. You can also get all the numbers in one row or one column. So the way to do that is, let's say you want to get all the numbers from the first row. You specify the row, as I mentioned before, row 0. And since we want the numbers at all the columns, we're going to use a colon. And the same thing for selecting all the variables in the same column. So let's say we want to choose all the numbers from the second column. So the second column is at index 1. And we want to choose all elements in that column. So we use a colon here. So let's see what we have. All right, so all the numbers in the first row is 1, 2, 3. That's correct, right? 1, 2, 3. And the numbers of the second column is 2, 4, 3. So 2, 4, 3. That makes sense. You can also get a submatrix by using index slicing. Here I try to create a new NumPy array B, which is a submatrix of A. So we try to access all the rows from 1 to 3 exclusive, and for all the columns from 1 to 3 exclusive. So let's see what we have. B is 4, 5, 3, 5. Yeah, we can see that all the rows from 1 to 3 exclusive is this row and this row, right? And all the columns from 1 to 3 exclusive is this column and this column. So that's why we get 4, 5, 3, 5. You can also select random rows and columns as well. So instead of just providing a single row or a single column index, you can provide a list of indices. So let's say here, we try to select column 0 and column 2. So we can provide a list of 0, 2 here. And you can put a colon here. That means you select every single row. Let's see what we have for B. So for B, it's going to be 1, 3, 3, 5, and 1, 5. So let's take a look at A. So we select the first column, so 1, 3, 1. That makes sense. We select the second column, so 3, 5, 5. That makes sense too. So next, we're going to talk about Boolean masking. So here I create a NumPy array, which is a 3 by 3 array. And I select all the elements that is greater than 4 and store that in B. So let's see what we have for B. B here is going to be a 1D array, and it contains all the elements in A that is greater than 4. So you can clearly see that 6 is greater than 4, 5 is greater than 4, 5 is greater than 4, 7 is greater than 4, 10 and 11 are greater than 4. We can do more complex logic, such as we want to select all the elements that is greater than 2 and less than 10. So let's see what we have. So we also receive a 1D array containing 4, 6, 5, 5, 7. So all of these elements are smaller than 10 and greater than 2. Next, we're going to talk about different ways that we can initialize a NumPy array. So the first way is to initialize a NumPy array with all zeros. NumPy has a function called zeros, and we can just provide the shape of the NumPy array as an argument. So in this case, I create a 3 by 2 array that contains all 0. So let's see what we have. So this is a NumPy array of size 3 by 2 and only contains 0. We can do the same thing for 1, right? So instead of creating an array with just 0, now we create an array with just 1. And here we create a 3 by 3 array. We can also create a NumPy array that has a random value that we choose. So NumPy has a function called full. In this function, we can provide the shape of the array and the random value that we want to put as the initial values. So in this case, I create a NumPy array of size 3 by 4 and it only contains 2. And also, you don't need to remember all of this. Just keep it in the back of your mind that you can do some operation like this. And when you actually need these operations, you can do a quick Google search and figure out the details. Let's move on. The next thing you can do is to create an identity matrix. So an identity matrix is a matrix that only contains 1 in its diagonal. So I create a 4 by 4 identity matrix here. So it only contains 1s in its diagonal and the rest are 0. Also, you can create a random matrix with value between 0 and 1. So NumPy has a submodule called random. So this module allows you to create random values. So in this case, I create a random 2 by 3 matrix. And so I call numpy.random.ran and then provide the size of the matrix, which is 3 by 2. I can also create a 3 by 2 by 2 matrix by providing more dimensions to this function. So let's see what we have. Alright, so for the 3 by 2 matrix, we can see that we got 0.83, 0.958, 0.33, 0.05, 0.48, and 0.67. For the 3 by 2 by 2 matrix, we get 0.959, 0.52, 0.87, etc., etc. You can go even crazier with this by adding more dimensions to this random function. So you can create an even space distributed array with NumPy. So NumPy has a function called link space. So this function requires a starting number, the ending index called stop, and the number of elements in that array. So what it does is it will create an array that starts at 1 and at 10, and then it contains exactly 15 numbers, and those numbers are evenly distributed. So let's see the output of this. So we start 1, right? And we end at 10. And we have exactly 15 numbers in between them. So the distance between two consecutive numbers are equal across all pairs. Alright, you can also create an array with the start and stop positions using a function called arrange. So this function takes in start, stop as the ending point, and the step. So we want to create an array that starts at 2, stop at 10, and we're going to step 2 every single time. So let's see what we have. So we're going to create an array of 2, 4, 6, and 8. Right? We don't include 10 because the stop variables is exclusive. So next, let's see how we can organize arrays. So here I'm going to create an array A, which is a 2 by 3 array. So let's see what we have. So 1, 2, 3, 3, 1, 2, and the shape is 2, 3. We can easily reshape this array into a 3 by 2 array. So we can call the function reshape. Let's see what we have. So now B contains all the elements in A, right? But now the shape of B is 1, 2, 3, 3, and 1, 2. But be careful, we can only do that if the multiplication between the dimension of A is equal to the multiplication in the dimension of B. So let's say we try to reshape A to a 3 by 3 matrix. We're going to get an error because 3 times 2 is 6, but 3 times 3 is 9. So we cannot convert 6 elements to a 3 by 3 array. Python already throw an exception here. Value error cannot reshape array of size 6 into shape 3, 3. You can also stack different arrays on top of each other or side by side. So here I create two NumPy array A and B, which is a 2 by 3 array. We can do a vertical stack. So a vertical stack means we stack the two arrays on top of each other. We stack B on top of A. Actually, we stack A on top of B. So we have 1, 2, 3, 2, 3, 4. We can also stack the array horizontally. So here we stack B to the right of A. So we have 1, 2, 3, 2, 3, 4. That was A. And 2, 3, 4, 5, 1, 6. That was B. And be careful here. We can only stack arrays that have compatible size. So in this case, we have A, 1, 2, 3, 1, 2, 3. The size 2 by 3. But B is only 1, 1. So the size 1 by 2. So if we try to do a vertical stack, let's see what we have. So Python will throw an exception. It says that all input array dimensions, except for the concatenation axis, must match exactly. Right? So that means we cannot match a 2 by 3 matrix with a 1 by 2 matrix. Alright, so let's get into the mathematics of NumPy array. So for NumPy, you can do some basic operation such as calculate the mean, calculate the max, find the sum of all the elements, find the mean, find the variance, and find the standard deviation. So these are very basic statistic calculation. So let's run this. So the mean of A is 1. The max of A is 3. The sum of all the elements is 12. The mean of all the elements is 2. The variance is 0.66. And the standard deviation is 0.816. Alright, in NumPy, you can do something called broadcasting. So this is a very interesting thing with NumPy. You cannot do this in a normal Python list. So here I create a NumPy array, a normal 2x3 array. And I create a new NumPy array called B. And B is equal to A plus 1. So what Python does is it will broadcast 1. It will broadcast this plus 1 operation on every single element in A. So let's see what we have in B. So B is 2, 3, 4, 3, 4, 2. So basically, we add every single element in A by 1 and then assign that new NumPy array to B. You can do that with subtraction as well. So we create a new variable B. We subtract every single element of A from 2 to get B. We can do the same thing for multiplication. So you can take broadcasting a step further by broadcasting across multiple arrays. So let's say we have A is a 3x3 array, and we have B, which is a 1x3 array. And we try to add them together. So let's see what we have. So the result array is 3, 5, 7, 4, 6, 5, and 6, 5, 7. So what we do is we take B, right, and we add that to every single row of A, element-wise. So we add 2 to 1, we add 3 to 2, we add 4 to 3. So that's why we get 3, 5, 7. We add 2 to 2, add 3 to 3, add 1 to 4. That's why we get 4, 6, 5. And we get 4 to 2, add 2 to 3, add 3 to 4. That's why we get 6, 5, 7. So that's how broadcasting works with multiple arrays. You can do some basic linear algebra with NumPy as well. So here I create two NumPy array, A, which is equal to 1, 2, 3, and B, which is equal to 3, 4, 2. So if we multiply A with B, we're going to get 3A6. So this star here, this multiplication here, we multiply two NumPy array element-wise. So it multiply 1 with 3, 2 with 4, and 3 with 2. You can also do a dot product with two NumPy array. What a dot product does is it will multiply all the element-wise and then sum up all the multiplication together. So basically, it will perform this operation here to get 3A6 and sum up all the elements in this 3A6 array. So 3 plus A is 11. 11 plus 6 is 17. So that's why we get 17 here. We can also do a cross product between two arrays. So let's say A is a 3x3 array and B is a 3x2 array. And notice that we can only do this if the value for the column of A is equal to the row of B. A has 3 columns and B also has 3 columns. And that's why we can do this cross product. So if we multiply A with B, we can call the function mathmul, and it will result in a new matrix outside 3x2. So you can also calculate the determinant of a NumPy array. So in NumPy, there's a submodule called linear algebra, and it has a function to calculate the determinant. So you basically just pass in the NumPy array, and it will calculate that for you. So you can also create an inverse matrix of a NumPy array. So an inverse matrix is a matrix in which when we do cross product, we get an identity matrix. So let's say for A, we got 1, 2, 3, 4. We're going to calculate B as the inverse matrix of A. So we're going to calculate linear algebra.inverse, and we're going to pass in A. I'm going to bring B to the console. I'm going to do a cross product between A and B. So this is B, and the cross product of A and B is an identity matrix, right? So we see that the diagonals are 1 and the rest of the value are 0. So this value is very small, so it's close to 0. So let's say I have a NumPy array of size 3x3, and it contains all the values between 1 and 9. So you can bring the 0 diagonal. So the 0 diagonal is this diagonal, the main diagonal. You can bring the first diagonal. You can bring the -1 diagonal. So let's see the result of this. So the 0 diagonal is the main diagonal, which is 0, 4, 8, right? The first diagonal is the diagonal one level up from the main diagonal, which is 1, 5. And the -1 diagonal is 3, 7. So we go one level down, 3, 7. So we can use NumPy to load some data from a text file. I already prepared a file called numbers.csv that contains 3 rows. And I'm going to specify the delimiter. In this case, it's a comma. So when I call this function, it's going to be a NumPy array of size 3 by 4. And finally, we're going to have a speed test with a Python list. So I already mentioned at the beginning of this video that a NumPy array is extremely fast. And now I'm going to show you that in action. So here I have a normal Python list that contains all the elements between 0 and 1 million. And I create a NumPy array between 0 and 1 million as well. So these two arrays contain the same elements. I will import a library called time to calculate the time that each array performs operations. So what we do is we're going to loop through every single element in each array and add 1 to it. So in Python, we have to loop through every single index and add 1 to each element at each index. And I will print out the time that Python takes to finish this operation. For NumPy, we can do broadcasting, right, as I showed you before. So basically, just add 1. This will automatically broadcast the add 1 operation to every single element. And I also calculate the time it takes to perform this operation. So let's see what we have. So the time to process a Python list is 0.106 seconds, right? But the time to process a NumPy array is only 0.001 seconds. NumPy array is 100 times faster compared to Python list in this test. So you can clearly see why data scientists love NumPy array, because when we process a bunch of data, we want it to be fast. That's it for this video. I hope you enjoy it. If you like the video, please like and subscribe. That supports the channel a lot. And I will see you in the next video. Peace.